Hello everyone, welcome to Nithin Academy and I'm Nithin. I really do hope you all have aced your PSLE exams and I do believe our PSLE videos have benefited you in some way. I do hope you all get into your dream school. If you do not get into your dream school, no worries. Like what you have when you don't have what you like. Okay? And today I'll be going through Secondary 1 Science, the first topic, Scientific Endeavor. Okay, so let's get started. Okay, for the first segment of this video, I'll be going through what is science. Okay, so what is science? Okay, what is science? So science is basically the study of natural phenomena in the world. Science is a human endeavor that is a result, of efforts in solving problems and uncovering answers to questions. Next, scientific knowledge is open to revision in the light of new evidence. And importantly, science is everywhere. Okay? So this part over here is actually not that important. This is for your own general information and this won't be tested in examinations. So you do not have to worry about that. Okay? So let's move on. Okay, for the second segment of this video, we have what are the attitudes in science. Okay? So what are the attitudes in science? Okay, so for the first attitude in science, we have curiosity. So curiosity, this is basically when a scientist shows interest, and particular attention to objects or events. Okay, so curiosity, this is when a scientist asks questions and seeks answers. Okay, so I hope you understood that. Now let's move on. So integrity. So this is the second attitude in science. So this is when a scientist gives a truthful report of observations and he does not withhold or fabricate important information just to benefit himself or others. Okay? Thirdly, we have open-mindedness. So this is when a scientist listens to and respects the ideas of others. He accepts criticism and is able to change his mind. So this is called being open-mindedness. Okay, to change his mind if reliable evidence contradicts his own beliefs. Okay, so fourth we have criticalness. So this is when a scientist bases suggestions and conclusions on evidence. So when the scientist is in doubt, he questions the validity of a statement in relation to the evidence presented. Okay? And lastly, we have creativeness. So this is when a scientist can generate new and original ideas. Okay? So these are basically the 5 attitudes in science, and this will be tested in exams. Okay, so take a look at this. Okay, so next let's move on to the next segment of this video. Okay, for the third segment of this video, I'll be going through variables in experiments. Okay, so variables in experiments. So variables and experiments. So these are basically like your primary school variables. Okay, so there's 3 variables, one being the independent variable, second being the dependent variable, and last being control variable. So all of these variables you have actually learned in primary school, except that they have different names now. So independent variable used to be change variable in your primary school, right? But in secondary school you're supposed to use this term known as independent variable. Okay, so independent variable is basically the change variable, and In primary school, you have learned the measured variable, right? But in secondary school, you're supposed to use the term dependent variable. And in primary school, you have learned constant variable, right? In secondary school, you can use control variable. Okay? Or you could even use the constant variable in secondary school. So in secondary school, these two are accepted to use. Okay? Both of this. Okay, so let's go through the meanings of each independent variable. So first, let's take a look at the independent variable. Okay? So independent variable. So this is where the condition in an experiment is being changed. Okay, so this is the independent variable. Next, we have the dependent variable. So dependent variable is basically what is being measured or observed as a result of what was being changed. So this basically means what is being measured or observed as a result of what was being changed. So basically they're telling us that the change variable affects the measured variable. Okay, so this is how you measure it. That's what they are basically telling us in the dependent variable. Okay, so next we have the control variable. So constant variable, the condition which was unchanged or kept constant to ensure fairness in experiment. Okay, I am pretty sure that you all are familiar with this, to ensure fairness in the experiment. So these variables are actually really simple because you've already learned them in primary school. Okay? Next, this is something important to take note of. So some investigations may make use of a control setup. Okay? So this control setup is basically one where there are no variables are tested. Okay? So this control setup is used to show that the experiment is valid and provides a baseline for which to compare the results. Okay? So basically there are two types of control. One is the positive control and one is the negative control. So the positive control is a setup that will always produce results. And a negative control is basically a setup that will not produce results. Okay? So this is important. You need to take note of this, and this is also important. Now, I think we can move on, right? Okay, so for the fourth segment of this video, I'll be going through the scientific method. Okay? So the scientific method. So this is something new that you'll learn in secondary school. The scientific method. So this is basically the steps of scientific method. So the first step in the scientific method is to observe. So you basically scientific method is used for experiments. So you're supposed to observe what is happening actually, and then you question. Thirdly, you hypothesize. I hope you have learned this in primary school. You're actually supposed to learn this in primary school. Hypothesize. You would have learned this. So hypothesize. What does this mean? So hypothesize actually means that, so hypothesis is basically a conclusion that is not stated to be true. Okay? So hypothesis and conclusions are closely related. So a hypothesis is basically a conclusion that is not stated to be true. Okay? So after hypothesis, we experiment. So basically we do the whole experiment and then we collect the results. So this is where we collect results at the same time. So we collect results. And then with those results, we actually conclude. Okay, so this is basically the scientific method. Okay, so here I have something. So in this experiment we are basically testing for freezing point. Okay, so we are testing for freezing point. So we are going to put pure water and salt water at a fridge in the freezer. Okay, and the next day we are going to see which one froze. So the pure water froze. Okay, so the pure water would have froze, but the salt water did not. So this is where you observe that the salt water did not freeze. And we are going to question, why did the salt water not freeze? Because salt water has impurities in them. So we are going to hypothesize. So a hypothesis can be true or false. Okay, so a hypothesis does not have to be true because only in the conclusion is supposed to be true. So hypothesis, we could hypothesize that the salt water has a lower freezing point than pure water, or the salt water has a higher freezing point than pure water. Okay, so salt water has a higher freezing point than pure water. Okay, so this is our hypothesis. Next, we are going to experiment. So, if salt water has a higher freezing point than pure water, if we put salt water into a more cooling refrigerator that may take negative numbers, so if we do that, and if the salt water freezes, it means that the salt water has a higher freezing point. Okay, and the conclusion would be that if the salt water freezes in a higher freezing point, that means we could conclude that the salt water, and that means that this hypothesis will actually be a conclusion. Okay, so this is basically how the scientific method works, and yeah, so I hope you understood that. Now let's move on. Okay, so for segment number 5 of this video, I'll be going through the type of data collected. Okay, so what are the types of data collected? So there's this one being quantitative data and the next one being qualitative data. Okay, so quantitative and qualitative. So let's take a look at what quantitative and qualitative data are. So quantitative data is basically is made with instruments such as rulers, balancers, cylinders, beakers, and thermometers. So quantitative data, basically these results are measurable, so they are in numbers. Okay, while whereas qualitative data, basically we have to use our 5 senses to observe the results. Okay, so basically our 5 senses: touch, sight, hearing, taste, and smell. Okay, so this is the difference between quantitative and qualitative data. Okay, so I hope you understood that. Now let's move on. Okay, so for the 6th segment of this video, I'll be going through the common physical quantities. Okay, so what are the common physical quantities? So this list over here is basically the common physical quantities. Okay, so let's take a look at it. So for the first physical quantity, we have time. So time, what are the things we have? So for time, what are the instruments we are going to use? So digital stopwatch, hourglass, and stop clock. Okay, and the units and the SI unit. Okay, so the units are basically hours, milliseconds, seconds, and minutes. Okay, so seconds is the SI unit for time. Okay, next, temperature, the physical quantity of temperature. So the instruments used are basically thermometer, thermocouple, and the probe. So the units are basically Fahrenheit, Kelvin, and Celsius. And the SI unit is Kelvin. So you should know that. Okay, next. We have mass, okay, for the physical quantity. So mass. So for the instruments used, we actually have beam balance and electronic balance, okay? So what are the units? The units are gram, ton, kilogram, pound, and ounce. So the SI unit is kilogram. Okay, so let's highlight that. So these are all important things that you are supposed to know. They might ask this in the examinations. Okay, so next, the physical quantity of length. So the physical quantity of length, we have instruments used, basically the meter ruler, vernier caliper, so I'll go through this more in depth later in this video, and micrometer screw gauge. Okay, gauge. And units, basically meter, centimeter, foot, inches, yard, and mile. So let's highlight the SI unit, meter. Okay, next we have volume. So volume, basically the instruments used are measuring cylinder, beaker, volumetric flask, pipette, burette, and displacement can and syringe. Okay, and the units are basically cm cube, meter cube, liter, and gallon. So the SI unit for volume is basically meter cube. Okay, next we have to take a look at force. So force, the physical quantity of force. The instruments used to measure force is basically the spring balance, and the units are basically newtons and kilonewtons, and the SI unit is basically newtons. Speed, next we have speed. Okay, so the physical quantity of speed, what we use to measure speed is basically a speedometer. And what are the units in speed? Meters per second, kilometers per hour, and miles per hour. Okay, and the SI unit is meters per second. Okay, next we have current, so electric current basically. So let me write that, electric current. So to measure electric current, we use an instrument called the ammeter. Okay, and for the electric currents units, we basically have ampere and milliampere. So the SI unit is basically ampere. Okay, lastly we have pH. So pH is basically a chemical property. So this is the pH scale, you can take a look. So this pH scale basically separates from acidic, neutral, and alkaline. So how do we know the pH value? Is basically when we take a sample from water and we put it into this solution, and we take a look at the colors of the solution, and the color that matches closely with the pH scale is basically telling us where that sample actually lies in the pH scale. So whether the sample is acidic, neutral, or alkaline. Okay, so you get to know that. So for pH, the chemical property, the instruments used is basically the universal indicator, pH 114, and there are no units for this. Yeah, so I hope you understood the common physical properties, and these are very important to know. Okay, So let's move on. Okay, so for the 7th segment of this video, I'll be going through accuracy versus precision. Okay, so accuracy versus precision. So this is basically a chart on precision and accuracy. So the first target we have is basically high in precision and low in accuracy. So let me just put high P, low A. Okay, and this chart over here is high in precision and high in accuracy. This target over here is actually low in precision and is also low in accuracy. Okay, and this target over here is low in precision and high in accuracy. Okay, so let's take a look at the difference between accuracy and precision. Okay, so the instruments we use can affect the precision of our readings. So let's take a look at what precision is. So precision is how close two or more measurements are to each other. So let's take a look at that, how close two or more measurements are to each other. See over here, high in precision, high in precision. So basically the shots are close to each other, so this means it is precise. So it refers to the refinement in a measurement and can be represented by a number of digits given. Okay, next let's take a look at accuracy. How we use the instruments can affect the accuracy of our readings. Random errors arising from human shortcomings and systematic errors arising from faults in the instrument can cause low accuracy. So here, two new words: random errors and systematic errors. Errors from fault in the instrument can cause low accuracy, and human shortcomings. So these two errors, random errors and systematic errors, I'll go through later in the video. Okay, so what is accuracy? So accuracy refers to how far the measurement deviates from the true value. So actually, see this point, this is actually the true value, this point over here, the center basically. Yeah, so the center is the true value. So over here is high in precision and high in accuracy. So let's just take a look at the accuracy point. It's high in accuracy because it's right at the center. Okay, so this target over here, it's right in the center, all the shots. So that's why it's highly accurate. Okay, and this is highly precise because none of the shots are in the center and all the shots are in one place. So that's basically precision is really high. And as for this, precision is low but accuracy is high because all the shots are very close to the center, and all of this are low in precision and low in accuracy. Okay, so I think you understand by now, so I think we can move on. Okay, so let's move on. Okay, so for number 8, for the segment number 8 of this video, I'll be going through random errors, like I said. So random errors. So random errors, how do we avoid random errors? So random errors are unpredictable and will shift the measurement from its true value by a random amount. So this is basically the true value, okay, over here, and it's always shifting it from a random amount. You can see that, right? See that? It's shifted from a random amount by a random amount. So let me just highlight that part. Unpredictable and will shift the measurement from its true value by a random amount. Okay? Errors arising from the environment may sometimes be beyond our control. Okay? Such as high wind, yeah, all of that. And human reaction time also cannot be predicted. Reacting too early or too late by different amounts of time can also cause random errors. We eliminate random errors by averaging or repetition. So you have learned this part in primary school, right? averaging or repetition. So we do that to ensure fairness and keep reliability. Okay, check. Okay, so I hope you understood that. Now let's move on. Okay, next we are going through systematic errors. Okay, so this is basically systematic errors. Okay, so how do we avoid systematic errors? So systematic errors are basically consistent. Okay, take a look at that. It's consistent over here as well, and will shift measurements from their true value by the same amount all the time. So you can see that it's all at one place, shifting by the same amount, okay, from the true value. So that's what they mean by will shift from their true value by the same amount of time all the time. Yeah, and they usually arise from problematic instruments, okay, such as poor calibration or zero error. So zero error I'll be going through in the next slide, and this is an example of zero error. So this is how the instrument is supposed to be pointing exactly to 0, but this, as you can see, is not pointing exactly to 0. So this is like a 0 error, and this is basically a vernier caliper. I'll go through this later in the video, and this too is a 0 error. As you can see, it's not perfectly aligned with the 0. Okay, so let me go through 0 error. So 0 error. So 0 errors are basically systematic errors. Okay, so let's take a look at this weighing scale. Nothing is placed and the reading is minus 200. So the reading is minus 200 grams. Okay, next, there's an apple placed. So a 200-gram apple is placed and the reading is 0 grams. So can you see that from minus 200 plus 200 is basically 0 grams. So this is how we actually calculate 0 error. So this is how we use instruments when there's a 0 error. So imagine we don't know the apple's weight, okay? So when we place the apple, we can see that it's 0, right? So from 0 to minus 200, how many kgs do we add? So we actually add 200 grams, right? Oh, sorry, not kgs, grams. So we actually added 200 grams, right? So that's how we can determine that the apple is 200 grams. Okay, next, a 300-gram sorry, not apple, grapes. It's not apple, sorry, it's grapes. A 300-gram grapes is placed. The reading is 100 grams. So basically you can see that again. So the reading is minus 200, right? And when it becomes 100 grams, how many grams difference is this? So this is basically 300 grams difference, right? So this is how we calculate the weight of the grapes. So the grapes, we can determine that it is 300 grams. Okay, so I hope you understood that. Now let's move on. Okay, so for the 10th segment of this video, I'll be going through parallax errors. Okay, so parallax error. So parallax error is basically when you need, so that there's 4 scenarios of the parallax error over here. So first scenario, to read the length of an object. So always you're supposed to view the object at eyesight, so basically perpendicular to the object. That then only you can ensure that the reading over here is accurate. So you can see that the readings are different when you take a look at it from different angles, right? Next we have a spring balance. Spring balance. So only when you view at it perpendicularly to the ruler, you can see the correct measurement. If not, it will be a different measurement. You can see that, right? Okay, so next we are going to take a look at it. So these two, remember, you need to take a look at it from a perpendicular angle. Okay, so next we have water and mercury. So water is the same thing as well. Water, we have to read eye level at the meniscus. So this meniscus is basically the concave meniscus. Okay, concave meniscus. So let me just write that, concave meniscus. So basically you have to read this line, okay, this line over here, not the top line. Okay, so it's 50, not 51. Okay, and same thing for this thermometer, mercury thermometer. So in the mercury thermometer, we have a different type of meniscus. So this is basically the convex meniscus. Okay, so convex meniscus is basically when it bends upwards, while the concave meniscus bends downwards. Okay, so it bends downwards. Okay, understand? So we have to read exactly where it bends upwards, so right over here. Okay, and same thing, eye level perpendicular to it, not from a different angle. If not, it will be a different reading. Okay, so I hope that you have understood the main point, that you're supposed to take a look at it at a perpendicular distance. If not, at a perpendicular angle. If not, it will be a different reading because of your angle of eyesight. Okay, so I hope you understood that. Now let's move on. Okay, so for segment number 11, we have the 9 hazard symbols. Okay, so let's take a look at it. Okay, 9 hazard symbols. So this is the first hazard symbol. So these are corrosives, and these may cause severe damage on contact with body parts such as eyes and skin. And this substance will eat away other substances. So basically, it will corrode the other substances, and it is a corrosive chemical. Okay, so basically very dangerous. Next, we have the irritant. So this is basically harmful or irritant. So the irritant basically has two symbols. So in exams they might ask you, what does this symbol mean, or what does this symbol mean? So you can just say this is the irritant. Okay, so they always trick you with this, and some people do not know that there are two symbols, so please do take note. So the harmful or irritant can lead to irritation, allergic reactions, or inflammation of the skin, eyes, nose, or respiratory system. It may cause drowsiness and dizziness, has harmful health effects, and can cause harm to the ozone layer. So basically this is also really bad. So you have to take the safety precautions before you use this kind of chemicals. Okay, next we have the environmental toxicity. So this has the potential to cause damage to living things in the wider environment. So it's basically a tree with a dying fish. Okay, and the tree is like, it has no leaves, so this can cause damage to living things, and also like trees and animals. Okay, next we have oxidizing substance. So this substance basically releases oxygen easily, which can cause a fire or an explosion. Okay, so next we have gases under pressure. So it basically looks like a gas cylinder. So it's stored in pressurized cylinders, may explode when heated, and it may cause oxygen deficiency if the gas is leaked in an enclosed space. So that basically means that there will be less oxygen for you to breathe, and you might die. Okay, so when you're in an enclosed space basically. Okay, Next, hazard symbols. This is basically the acute toxicity symbol, and it looks like a skull. Okay, it can cause toxic or harmful effects to the body when inhaled, swallowed, or on contact with the skin. Degree of exposure and toxicity can affect the level of health implications and may be fatal. Basically means that you may die. Okay, so this is actually really dangerous, and you have to take the correct safety precautions before you can use these type of chemicals. Okay, next we have explosive. So it basically looks like a bomb exploding. So it may cause fire or explosion, may cause an explosion on contact with heat. So basically like flash powder. Okay, next we have the flammable symbol. So it basically looks like a fire, and it is highly flammable, may cause fire or produce poisonous gas when reacted with air, water, or chemicals. Okay, next we have the carcinogenicity or aspiration hazard. So this can cause breathing difficulties and can cause infertility, birth defects, damage to organs or cashes. So infertility basically means so you have learned in human reproduction system, right? Basically when the mother's egg supposed to get fertile, but this can actually cause infertility. So you may not be able to give birth, and this birth defects, the baby might have like some problems and or damage to organs or cancer. Okay, so basically very dangerous. Take the correct safety precautions again. Yeah, so with that we have come to the end of the 9 hazard symbols. Now let's move on. Okay, so for segment number 12, I'll be going through the 10 safety rules in a science laboratory. Okay, so 10 safety rules. So the 10 safety rules in a science laboratory are basically, firstly, eating and drinking are prohibited in the laboratory. Long hair should be tied back to avoid any interference with laboratory work. So if you are using the Bunsen burner, basically it gives out fire. For the girls, if your hair is not tied up, your hair might catch a fire, and you have to go to the the shower where you have to pull the handle, and water will like come onto you so that it will extinguish the fire. So basically one of this has happened in my class before. So a girl did not tie her long hair, and when she was using the Bunsen burner, her hair caught on fire and she had to do the same thing. Yeah, so it's basically quite dangerous. So just do like follow this precaution whenever you're going to a laboratory. Just tie your hair back. Okay, and articles of clothing must not pose a safety risk in the conducting of laboratory activities. So for example, ties are not allowed in the laboratory. So ties are not allowed because same thing, you may like dangle, and fire might catch on fire. Yeah, so there's many safety risks, so we should not do that. Okay, next, safety goggles should be worn whenever there's a risk of injury to the eyes. Okay, this all simple. You all should know this by now. Okay, so these are all important stuff. Next, you have to wash your hands thoroughly before leaving the laboratory, regardless of whether or not gloves were worn. Okay, so even if you wore gloves the whole entire lesson, you're still supposed to wash your hands really very thoroughly, because you're handling with chemicals and all that stuff. Okay, next, work thoughtfully and purposefully. So playing around and other acts of carelessness are strictly prohibited. So you have to work thoughtfully and purposefully. So do not play around. Okay, because the laboratory has dangerous chemicals and is filled with glass items and expensive items. Okay, and expensive apparatus. So basically when you're playing around, you might knock down something, or or do something dangerous. So basically it's a safety risk, so you do not want that to happen. Okay, so next, report damaged equipment, breakages, accidents and spillage to the teacher in charge immediately. So this is very important. Many students forget this. So when something happens, do not try to take care of it yourself. You have to report to the teacher immediately, and I mean immediately. So you have to report to the teacher really immediately, like at the split second you're supposed to report to the teacher. Understand? Okay, next. For number 8, be aware of the location and the use of first aid and emergency facilities such as the emergency eye washers, showers, like I said, showers for fire, and first aid boxes and fire extinguishers in the laboratory. Okay, next, 9, chemicals or other materials must never be tasted unless specifically directed by the teacher. So do not taste chemicals, okay? That's dangerous unless your teacher tells you to do so. Okay, so lastly, for number 10, we have be mindful of where you stand in the lab. Example, never stand facing a test tube that is being heated by a Bunsen burner. So when you're standing facing a test tube that is being heated by a Bunsen burner, something might explode out of the test tube and it might hit you. Okay, so that's why it's dangerous. Next, let's move on to the next one. Okay, so I hope you understood the previous one. Now let's move on. So for segment number 13 of this video, I'll be going through safety rules for the use and disposal of glassware and sharp objects. Okay, so let's take a look at that. Okay, so yeah, so let's take a look at the first rule. So glassware should be stored or assembled in a secure and convenient manner. Do not store glassware too high or with heavy apparatus. So this is the first rule to take note of. Next, chipped or broken glassware should never be used because it may chipped or broken glassware may accidentally cut your hand, or it can be cause to can be a cause to spillages, and these are actually very dangerous because if you're using dangerous chemicals, it might get in contact with your hands or other body parts. Yeah, so do not use chipped or broken glassware. Okay, next, care should be taken when handling instruments with pointed ends or sharp edges. So sharp objects should be retrieved and accounted for by teachers at the end of the lessons. Okay, so like scissors, there's knives. Okay, so all of these type of sharp objects should be given to the teacher, and the teacher will actually count them and make sure that all of them are retrieved. Okay, next, when not in use, sharp objects should be kept in a safe storage box away from students. Okay, so please do not take sharp objects when not in use. Okay, so it should be kept in a safe storage box. So the teacher will ask you to keep in this safe storage box, and the teacher will account them for. So please do return these sharp objects. Okay, next, broken glassware and shards should be carefully discarded into a puncture-proof container meant for sharp objects. So you can see over here. So these type of objects actually go into this bin, this big bin with sharps. Okay, so if you accidentally break your test tubes or anything like that. Okay, next. Okay, next we have segment number 14 of this video. So basically I'll tell you about the safety rules for the use of electrical devices. Okay, so electrical devices, safety rules. So there's an electrical hazard symbol over here. So do not use electrical devices with frayed or worn out insulation. Do not use electrical appliances with wet hands. Do not use electrical appliances that has sparks or smoke being emitted when it's switched on. Sorry, over here there's supposed to be electrical appliances. Okay, okay, so So do not use an electrical appliance that has sparks or smoke being emitted when it's switched on. Next, do not place electrical devices near water sources. Do not overload an electrical socket. So yeah, there it is. And do not attempt to repair an electrical device yourself, or just tell the teacher, okay? So there are many rules like this. Do not use electrical appliances that are not fully plugged into the socket. Okay, now let's move on. Okay, so for segment number 15 of this video, I'll be going through the Bunsen burner. Okay, so this is the Bunsen burner. Okay, so there are many parts in the Bunsen burner that you're supposed to know. Okay, so let's go one by one. So first, let's take a look at the gas hose. So the gas hose is basically this part over here. Okay, this part actually is to carry the gas from the gas tap and to go into the Bunsen burner for the flame to spark. Okay, next, metal base. We have a wide and heavy. So the metal base is wide and heavy so that the Bunsen burner is less likely to topple. Okay, we have the air hole over here. So the air hole is basically to allow air to enter the Bunsen burner. The collar is basically this part. Okay, let me show you. The collar is basically this part over here, and the air hole is basically inside. Okay, and then this is the barrel. So sorry, the collar is turned to open or close the air hole to obtain the required type of flame. Okay, next we have the barrel. So the barrel is to basically raise the height of the flame for ease of use. Okay, so this is basically an extension to raise the height of the flame. So in the flame there's two parts. So this is basically the core part of the flame, and the tip of this inner flame is basically the hot part of the flame. Okay, so next, so we need to know the steps to light a Bunsen burner. Okay, so first we have to turn the collar to close the air hole, hold the lighter just above the barrel. Okay, so we have to hold it right above the barrel, like something like this. Okay, and then we turn on the gas tap with one hand. So imagine there's a gas tap over here. Okay, we turn on the gas tap with one hand. So there's one hand over here, and then the other hand we click the lighter. Okay, so I hope you understood that. And why do we turn the collar to close the air hole first? Because if we do not close the air hole, air will be going in. Okay, and then there will be a strike back. So instead of the flame lighting over here, you actually light over here inside the, and this is really hot. So we do not want this to happen, and it's very dangerous. Okay, so that's why we have to always take the safety precautions. Okay, let's take a look at the next slide. Okay, so next slide. So we are going to take a look at non-luminous flame versus luminous flame. Okay, so this is a luminous flame and this is a non-luminous flame. So what do we have in a luminous flame? So luminous flame is basically orange. Okay, orange non-luminous flame. So this appears when the air hole is closed. Okay, so because when the air hole is completely closed, so it appears flickering and unsteady and is not very hot compared to the blue flame. Okay, so very little air mixes with the gas and is not suitable for heating because it's unsteady and is not very hot, and carbon particles get deposited on the apparatus. So if you're heating a test tube, right, the under part of a test tube will be really black. Okay, and on the other hand, if you use the non-luminous flame, the non-luminous flame is blue. It burns steadily, so it is straight, so it's easier for us to heat, and it's hotter than the luminous flame, and the hottest part of the flame is just above the dip of the blue zone, so right over here. So this is the hottest part. And is suitable for heating and occurs when the air holes are open. So when you're lighting it up, first you have to close the air hole, you light it up, then you open the air hole. Okay, so you basically turn the collar to open the air hole, and then you get this kind of flame. Okay, so basically open air hole. Okay, and free airflow into the burner. And unlike the luminous flame, there will be no carbon particles. So carbon particles is a no. Okay, so yeah, let's move on. Okay, so for segment number 16, I'll be going through, so this is the last segment of this video, I'll be going through laboratory apparatus. So this is the very important thing we need to know. So let's just take a look at it. Okay, so laboratory apparatus. So in exams, right, they're actually testing us to draw apparatus apparatus from the lab. Okay, so they might ask us to draw the Bunsen burner, tripod stand, test tube, boiling tube, retort stand, conical flask, round bottom flask, beaker, filter funnel, gas jar, evaporating dish, bell jar. Okay, so these are basically uh, uh, the most important laboratory apparatus. So basically these are the common ones. Okay, so Bunsen burner, the function is to raise a flame above the table surface high enough for heating. Okay, so this is how you draw a Bunsen burner. So it's basically just one arrow, okay, and then you put heat below. Okay, so this is how you're supposed to draw it. So they might test drawing of apparatus in your exams. Okay, and then tripod stand, really easy to draw. Tripod stand actually supposed to have 3 legs, right? But then for drawing's sake, we don't use 3 legs, we actually just use 2 legs. Okay, because one of the legs will go behind this one leg. Okay, that's why it's only 2 legs. So many students get confused when when the examiners ask you to draw tripod stand. Instead of drawing just 2 legs, they draw an extra leg. So that's where they get penalized and lose many marks. Okay, so basically you're just supposed to draw it like that. Okay, I can't draw it properly here, but you can see the image and you will know how to draw it. Okay, so the basic property of a tripod stand is to support apparatus during heating. Okay, so it's to support other apparatus. So basically if you are using an evaporating dish, right, so here's the evaporating dish, and then we have a Bunsen burner here. Okay, so this is basically what we use the tripod stand for. And then on top of the tripod stand, right, there's always this one thing over here. It's basically the wire gauze. Okay, so there's a wire gauze when you're using the tripod stand. Okay, so yeah, just take note of that. Next, we have the test tube. So the test tube is to contain small amounts of chemicals for heating to mix solutions and liquids. Okay, so this is basically how you draw a test tube, something like that. Okay, next we have the boiling tube, to contain chemicals for strong heating. So important, strong heating. Okay, to collect and hold liquids. So how do you draw? It's basically slightly thicker than the test tube. Okay, so you just need to differentiate the test tube from a boiling tube. Okay, next we have the retort stand. So the retort stand is also to support apparatus during experiments. So one of the purpose of the retort stand is to basically hold a thermometer. Okay, so imagine this is a thermometer. Okay, and then we have the beaker over here. Okay, wait, let me draw it properly. So we have a thermometer over here, and then we have a beaker. Then we can keep constant measurement of water, and then maybe there's like some ice cubes here. Okay, so we can check the temperature of water when the ice cubes slowly melt. Okay, just to like keep constant measurement. Okay, I hope you understood that. Okay, next, conical flask. So this is how a conical flask looks like. Okay, so conical flasks are basically to contain and mix chemicals and liquids. Okay, round bottom flask. So basically it's in the name itself. It has a round bottom. Okay, so to mix and heat chemicals and liquids evenly. So if you want to heat chemicals and mix chemicals and liquids evenly, you have to use a round bottom flask. So there's different functions for different apparatus, and you can understand that just by the difference of conical flask and round bottom flask. Okay, next we have the beaker. So the beaker is to contain chemicals and to collect liquids. Okay, and also to measure. Okay, you can measure in the beaker. Okay, next, filter funnel, to transfer liquid into container with a small opening to separate solids from liquids. So filter funnel, we usually use it to separate solids from liquids. Okay, so this is an experimentation for filtration. So basically there's like some paper over here, and then you pour like if you pour the water with sand in it, basically the filtrate will come over here. Filtrate. So the filtrate is basically the pure water, and then the residue will go over here, which will be the sand. Okay, so these are like basic experiments that you Sec 1s do. Okay, just a brief. When I'm going through the other topics, you'll soon to get the hang of this. Okay, next, the gas jar. So gas jar is basically to collect gas. So this is how the gas jar looks like. Okay, so this is basically to collect gas. So you need to know these functions. Okay, if not, it's kind of hard to understand. So evaporating dish, to evaporate the liquid of a solution over a Bunsen burner. So this is basically to separate salt from water, because it's really hard to separate salt from water, because there's no other method to separate salt from water. So this is like a basic experiment that you guys do in secondary school. And so basically how it works, right, is basically using this tripod stand. So there'll be a tripod stand over here. Then there'll be some wire gauze over here. And then there will be a Bunsen burner over here with heat. Okay? And then over here is the solution with water, and this basically the salt solution. Okay? So over time the water will evaporate and remaining will be salt. So there will be like this white substance like sticking to the edges of the evaporating dish, and that's how you obtain salt from water, from salt solution. Okay, and then so these are like some of the basic experiments that I'm telling you guys. And then this bell jar right over here, next one, bell jar. So bell jar is to separate the setup of an experiment from its surroundings. So basically if you do not want any surrounding factors to affect that setup, you just put a bell jar over it, and the surroundings can't affect the setup inside. Okay, so these are basically all the laboratory apparatus, and with that I've come to the end of the video. Yes, and thanks for watching everyone. I hope you have enjoyed this video and understood more about Secondary 1 Science, the first topic of scientific endeavor. And I hope this really helps you. And please, if you're not subscribed to Nithin Academy, please do subscribe and be a part of our family. And thank you and bye-bye. See you again next video. Bye.